My colleagues here, if you haven't heard, this is a push-to-talk system, so you're like the little boy with his finger in the dike. The first thing that we do want to do is hear from Robert Lightfoot and get an update on the perspective of NASA here. And it's been my privilege to be here many years from time to time. Robert, you need no introduction, so we will just turn the floor to you. Thank you.
And panel members, and thank you for what you're doing for the country. I think this is an important endeavor, and having listened to some of the deliberations yesterday, you have quite a challenge on your hands, and maybe we'll help you with it. Maybe we'll add to your challenge. I don't know. We'll see how the day goes. Welcome to Huntsville. Welcome to North Alabama. We appreciate you guys coming back. Several of you were here with us last month and got to see the site. I was telling my wife this morning, this is kind of like a concert tour for a young guy, right, from my younger days. And you guys you need to sell shirts, right, as you go on this trip around the country. So we appreciate you making Alabama your second stop on your 3-day tour coming through here. So we'll see if you're all selling T-shirts afterwards. So that'll help us out. I intend to give you a little bit of an overview of where we are and what we do here and what we think our roles are from a Marshall perspective, and then talk about our capabilities a little bit. But I'm going to close with a perspective that I think you guys have asked for from the Center Director's spot. Next chart, please. So this is the roles we feel like we have at Marshall. We're responsible for lifting from Earth, living and working in space, and understanding our world and beyond. And I'm going to touch on each of those as we go through, and we make contributions in each of those areas. Next chart, please. The legacy for Marshall, you can see, and most people know, you can see it hanging out here in the Davidson Center is with the Saturn V. We started back in the Apollo days. We're currently working the shuttle, as you guys know, and that is not that long bar that says shuttle. Recognize that there's been a lot of improvements and a lot of work done during that time, development activities, Block 1 engines, Block 2 engine, updates to the RSRM, and then our super lightweight tank efforts, and of course the foam efforts that we've been through after Columbia. We also have spent a lot of time with, got ahead of me there. We also spent a lot of time on the future transportation systems development that you guys have probably seen, a lot of the acronyms, as we call it. But those have actually provided us quite a bit of technology development as we've gone along, and we've factored all that in as we've gone forward. But that's most of the roles we've been playing. And then finally, of course, we're working Ares 1 and Ares 5, and you're going to hear more about that today from Steve and his team as we go forward. Next chart, please. The other thing that we do that probably isn't as obvious to the outside world, since most people think Rocket City, we do rockets, is we do a lot of living and working in space activities. And I think the important piece to know is that we started that kind of with Skylab. And all along we have been very big in the development of payloads and payload operations and payload racks. We did a lot with Spacelab, worked with them to do that. Today, for Space Station, we're supporting them with the oxygen generation system, the water recovery system that's up there now. And it allows us to get involved with how to live and work there. And I'll talk about that a little bit when we talk about the capabilities. Some of you saw our ECLIS system when you were here, or our ECLIS lab when you were here before. Those guys are doing some really interesting stuff that will allow us to kind of extend this venture past low Earth orbit. We also provide the microgravity research rack that goes on the station where we do all the science, and the material science research rack as well. So I think that combination is a bunch of skills we have at Marshall that folks don't realize in the support that we do there. The other thing that I'll point out is we've done a lot with the nodes. We've managed those. It's not just doing the work, it's also the program management that comes with it. And then finally, we have the Payload Operations Center here. 24/7, all the payloads on the station come through Marshall Space Flight Center to get the work done. And that's recently cranked up from 2 or 3 countries to about 15 with the addition of the Columbus module and the JAXA Kibo module on the station. So our Payload Operations Center is very busy. They're also the backup control center for Houston, and after Hurricane Ike last year, we had about 35 folks, 35 of our colleagues from Mission Ops in Houston come over and run station from here. So it was a good checkout for us. Next chart, please. So the other piece of this that I won't spend a whole lot of time on, I just want to point out, is we do a lot of the work in science. A lot of folks don't realize we managed Hubble and Chandra. two of the greatest observatories, in my opinion, ever to go. But the important piece of this that I want to point out that relates to human spaceflight is, when you look at Hinode and the Lunar Precursor Robotics Program, this is how science can work to help human spaceflight. Hinode is helping us understand the sun. It's a Japanese mission, but we have a principal investigator here. And the things that we're learning about the sun will help us as we get out past low Earth orbit and start dealing with the effects of the radiation from the sun on the humans. And then the Lunar Precursor Robotics Program, the two missions that Ames and Goddard have put together, are going to help us understand where we might want to go on the moon when we go there. So that's what those guys are doing. Next chart. So that's kind of our roles, and those roles lead to a set of what we consider a set of capabilities. So I'm going to talk about each of these a little bit. The lifting from Earth, of course, that means we have to develop the transportation and propulsion systems and the development of the integration of large complex systems for living and working in space, and then, of course, the science side of it, understanding our world and beyond. Next chart, please. So for the transportation and propulsion systems, I think the important thing here is that these capabilities that we have here, they start at the program project management level. That's critical. I mean, we can't do anything if we're not managing the projects appropriately. Systems engineering and integration, if you look at every one of these systems is a complex system. You've got to have the integration piece, and we do that here very well. I think we have an organization dedicated to that in our engineering department, and then we have an integration group in each of our project offices that we have here that are responsible for that. The propulsion systems and components work we do, if you look at our propulsion lab in engineering, it's a group of folks that goes all the way from the valves, the lines and ducts, all the way to the turbo machinery, combustion devices, and the full-up system. And when you look at propellant management and delivery, we have teams that do tankage, they do main propulsion system work, and have been doing it for years. And they're the folks that do most of this for NASA in terms of getting that ready to go. The other piece that's important is modeling and simulation. You saw some of that, I think, those of you that visited with us before when we went to our Cedar room, where we talked about how the modeling and simulation plays into the design process, and how those tools have become very helpful in the design process to kind of give us some early warning of some issues we may have. And then finally, in the manufacturing area, we're doing a lot of things related to that are pushing that envelope on manufacturing, at least for space materials. And the guys, I think several of you saw it, it's not just the manufacturing and materials pieces, it's the processes that go with it, laying out the manufacturing flow, the things that we've got to do on the shop floor to actually put these things together in the right way. And I think you saw some of that with the friction stir weld work, and also with the work on the common bulkhead that we showed you when you were here before. Those are the kind of things that are gonna push us to the next level. Next chart, please. So in the large complex systems, again, it's the program project management area that we've got, and systems integration and engineering. Those could go across everything. The other piece that we do is the regenerative ecology. If you look, you guys, some of you saw it, some of you actually drank the water from our system. Our team was really excited, by the way. I got to tell you that when you guys picked the water up, like somebody started drinking it, they get it. So I laughed at Leroy because Leroy said I'd drink it if I had to, so, but he didn't pick up a bottle. But anyway, the team was very excited to show you what they do. And right now, they've gotten to the point where we've got a water recovery system on orbit, an oxygen generation system as well. That's part of the pieces that allowed us to go to 6 crew on station. We had to have that to be able to do that. So the team put that together. That lab, the work they're doing now will certainly be something we can morph toward any surface systems or any habitation work we want to do down the road. That's what we've got to have. The advanced concepts work that we do in architectures, you guys, some of you have had Reggie Alexander and his team brief you. That team does an awesome job kind of taking any scenario you can throw at them and putting the trappings around it, and they have some good tools and ability to model that out. And then one of the bigger things that we have is this tremendous testing capability that we have at Marshall. We showed some of you the stuff we were doing for thrust oscillation related to lock stamping in one of our structural test facilities. Those are the kind of things that you have to have. This is software integration lab where we do all the full-up hardware in the loop. Software integration is other stuff that's very important for us to be able to get through this. And then the propulsion testing and the big dynamics testing that we do will allow us to, it's just capability we have here that is hard to match. We're also working technology maturation stuff. We're working with ETDP from ESMD. We're doing some things related to the descent engine technologies for a lander. And our teams are working that, plus some rad hardening for the electronics that got to get out into space. Next chart, please. Then on the science side, again, this is just kind of a list of some of the science stuff we do. The one thing I'll point out that I think is important for the human spaceflight piece is the bullet at the next to the bottom there is the in-space propulsion or propellant propulsion and surface systems power or surface power system. We do a lot of work with Glenn Research Center in this area with the surface power systems. We've got some nuclear capability out here that allows us, or simulation, I should say nuclear capability, simulated nuclear capability that allows us to test potential systems that allow us to be on to survive on the moon. We also are doing some in-space propulsion work with Glenn, and then the cryogenic fluid management and things that that we're going to have to do on orbit once we get to that point is an area we've been working on for years here. Next chart. So we kind of feel like we've got the full life cycle capabilities, and we think that full life cycle is important. If you'd hit the next chart for me. It starts with the advanced concepts. I showed you guys this, some of you this before, and just wanted to get it as part of the record. The advanced concepts is important. That's where you kind of lay out what you're doing. Next chart. Then you go into technology development, where you take okay, what am I going to need? Where are my technology items? And that's the area that we do here, especially in the manufacturing arena. Next chart. Then we start the design and analysis process, and it's very iterative at this point, where we go back and forth between these two, so that the teams are all there to do that. Next one is of course, manufacturing. And an important piece about manufacturing, and I didn't point it out early, is Michoud Assembly Facility belongs to Marshall Space Flight Center. It's one of our satellite spots. A couple of you went down there with us to see that site. What we do here at Marshall is we kind of develop the one-offs and how we're going to make these things work, and we send them to Michoud as part of the production and part of the to begin to integrate what we learn here down there. And I think when you guys saw the friction stir welding that we did for one of the domes, you recognize that the Boeing guys were there, the Michoud guys were there, everybody was there that was going to take that down. Next chart. Of course, you've got to integrate all this into an assembly and test it. We've got the capability to do that. If we have a software integration lab, we have full-up ISTA and integrated systems test article that's going to have the upper stage and the J2 tested for the first time. That'll all be done on test stands that are sitting here left over from the Apollo days. And then, of course, the last piece is the operations and sustainment. I think it's really important to recognize that you have to kind of be tied into the operations piece to know what to fix in the design cycle. So Marshall's got that, and that's what we think the systems engineering does for us. But I'll tell you, we don't do this alone. This is not something that just Marshall does by itself. We're just a key part of the agency with these capabilities that allows us to bring to bear what we bring to the human spaceflight story. Next chart. And what I want to touch on here a little bit is, because you guys ask about this or have it in your charter, is the industrial base. I think a lot of people, when we talk industrial base, they get just a commercial or an industry piece of that. And I think when you look at Marshall and Kennedy and Johnson and Stennis from a human spaceflight perspective, we are part of that industrial base. We're part of the national capability. We have a lot of agreements in place, as you see, 70+ Space Act agreements, and these are agreements where people come in and use our capabilities, our people, our facilities to do things that they might not be able to do in their own company. And I think that's an important thing to recognize. We're not the only ones that do this, by the way. Most of the centers do this. And I think we have a history of sharing those capabilities with the industry. And I'm going to talk about that a little bit when I give my perspective, because I think that's an important piece. So when you guys think industrial base, I hope you recognize that the NASA sites are part of that industrial base that allows us to do human spaceflight. So that's kind of what I wanted to show you from a next chart, please. From a perspective of the capabilities at a real high level, of course. And then the intent of that was just to kind of give you an idea that the extent of the human spaceflight capabilities here, but also the fact that they are part of a much larger capability that the agency has, and frankly that the country has, from an industrial base perspective. It's a little bit of a I don't know, you got kind of it's not an exciting presentation, right? Not any videos. They asked me earlier if I had embedded videos. I'm going, oh God, no, I can't do that. Only my buddy Steve can do that. But what I want to point out is, from my perspective, is that this is not a time to be passive about our future. Okay? I think, from my place, and you've asked for the center director's perspective, and from that perspective, I think we're kind of at a crossroads for human spaceflight. I think it hangs in the balance a little bit, and I think that if I sat here and just gave you that pitch you just saw, it would almost be as if I was silent or indifferent to what you guys have on your plate and what you have in front of you. And I wouldn't be representing my team at Marshall or this community that's probably invested most of their time in human spaceflight or their careers. So you asked for challenges. We got a bunch of challenges. There's a lot of challenges. We'll always have technical. We'll always have workforce. We'll always have infrastructure and resources. Those will always be there. This is part of this business. Anybody that's been in it for a while, I don't think I've ever had a budget that was good enough. Okay? I mean, that's the way it's been since I've been here. That said, for me, the biggest challenge is maintaining the capabilities that we need for the future during this gap. I heard you guys talk about the gap yesterday. We've gone through a really strong process to establish what constellation needs that we have today that shuttles carrying. And so I think we got a good feel on the what. The question is the when do they need it, and that's when it sometimes becomes problematic because they may not need it for 3 or 4 years. And so what do we do? And that kicks off a whole other process for us. So that's a big challenge. But I want to be really clear. It's not the facilities and the infrastructure that I'm worried about. It's the people, because the people we have is where our intellectual capability is. And the folks that work at Marshall, Johnson, and Kennedy, they are a national asset, period. And I hope you guys take that away. So I think that's probably the biggest challenge. There's a lot of challenges, but I think that's the biggest one. I didn't want to load your plate. I heard you talk yesterday, and I think you know some of the other challenges that are out there. As for a perspective on human spaceflight, perhaps the events of the past week summed it up for me the best with the 40th anniversary of Apollo. The focus last week was on the people. And I think if you all take a little bit of time and think about human spaceflight, think about the images you have kind of etched in your brain when it comes to human spaceflight. For me, it's obviously Neil Armstrong and Buzz Aldrin walking on the moon. It's John Young pumping his arms when he's walking around the Columbia after the first landing. So excited about what we've done. It's John Grunsfeld hanging on the end of the robotic arm, silhouetted against the Hubble Space Telescope. The best example of human spaceflight and science together. And then it's Pam Melroy and Peggy Whitson sharing an embrace when 120 has joined the station for the first time to have a female shuttle commander and a female station commander. Each one of those represents an incredible technical achievement. I mean, I could tell you the technical piece of all those. But what's interesting is the human piece, and the piece that how that relates to us, and how we as humans can take that and grab our attention. We're driven by the natures of our successes and failures, and sometimes cynicism can run kind of high. In this 24/7 world that we live in, it's pretty easy to get everything out in the public eye so quickly. I sometimes wonder today if we would have continued Apollo with the early launch failures that we saw, if they were so public. And I wonder if we'd continued shuttle. I remember test engines blowing up in test stands early on too. It's part of the process. I think our memories forget that forging this new frontier is hard. It's full of challenges. So why do we choose to explore with humans? I had to be reminded of my own reason for pursuing a career in human spaceflight business. And frankly, I had to peel back some of that cynicism and scar tissue that gets built up over the years to be reminded. And it was standing, when this rocket that's out here was outside, I was standing at the end of it looking at the F1 engines. Just had taken a propulsion class in college. Had no idea what a rocket engine was, but boy, I could do the math, no problem. And to see that F1 engine, I thought, wow, this is pretty cool. This is actually that's what I've been studying. And it drove me to get interested in engines and engine testing. And so I followed on and became a space shuttle main engine test conductor and just loved it. That was my favorite time of my life is running test and trying to make the improvements to the engine that we needed to make to get to be a better engine. And it gets in your blood, it kind of gets in there and you can't get it out of there. And even today, when we get done here, I'm going down to Stennis. If you don't think transition is real, today is the last planned SSME test at Stennis Space Center. Now, I probably won't make it in time for the test unless they have some lightning, which I'm kind of pulling for. But but I will at least get down there and see who I really want to see, which is the team. My peers, my buddies, the folks that really were part of my career, have been part of my career all along. The point is that when you think about that piece of it, for me it wasn't the rocket engine down at this end that intrigued me as much as it was that little bitty capsule at the other end carrying the 3 people and what we needed to do to make that better. It's no different than when we have the shuttle crews come to Marshall Space Flight Center and recant their missions. You guys, Sally and Leroy have done that, I know. When they come in and recant their missions, we always invite at least 2 or 3 elementary school classes to come. They can bring all the pictures they want, but without them sharing their thoughts, their perspective, it's just a book. They allow us to put the human part of that is what grabs our attention. I spent some time with our younger folks here last week. Got lucky. Got real lucky, actually. I had a meeting with them. They were presenting some things on actually retaining talent. How do we keep them interested here at Marshall? So knowing I was coming here, I said, hey, I got a job for you. And I handed them out index cards and said, tell me why NASA? Because these are some sharp folks. Man, they are sharp. Why NASA and why human spaceflight? And needless to say, they threw my index cards away and they sent me emails. So I didn't get any index cards. But I did get a lot of input. And the funny thing is that when they left that room, they went back and they kind of started their own little network of, hey, Mr. Lightfoot asked this question. What are we going to go do? Well, I got a ton of emails. So what I wanted to do was just share some of these. This is very inspiring to me, and it gives me great hope for the future when I hear what these folks said. Why NASA? NASA is my dream job. Another one said, want to be part of making the greatest discoveries ever made. Another one, my desire to work for NASA has been my motivation to succeed my entire life. I wanted to be part of a team that makes the impossible possible. Some of those guys are here today. Then ask them, what about, why human spaceflight? You got to realize, these folks are probably about 20 years old, 22, 23 maybe, the max. Why human spaceflight? Exploration and the challenge of the unknown provide the opportunities that an individual and society need to fulfill their potential. Great challenges precede great results. Human spaceflight is such a challenge. Another one, we are the first and maybe only species that has the ability to potentially extend our biosphere beyond the confines of one world. It would be a shame to waste that potential. When we left Earth's orbit, we crossed a line and there's no going back. Stopping now would be like Christopher Columbus stopping in the middle of the Atlantic. And then the final one that I picked up. To me, there are 2 main factors that drive us to explore our solar system: natural curiosity and concern for our future. The first of these factors makes further exploration inevitable. The second dictates that exploration occur in a timely and thoughtful manner. The only question in my mind are how much do we want to invest in this inevitable venture? How much do we desire to remain at the forefront of this frontier? And how long will it be until myself or my children experience the sense of global unity that resonated around the globe when man first set foot on the moon? 20-year-olds. I think we got a good future. I think we're okay. With all that background and recognizing that we at this agency implement policy and don't set it, I would like to share with you from my perspective, since you asked for it, the outcomes I most wish from your efforts. First, I think we need to extend the International Space Station. We continue to learn from this magnificent platform how to live and work in space. Whether it's studying the effects of long-term exposure on the human body, or whether it's just learning how to fix a carbon dioxide removal assembly that we did this weekend. That's what we're learning. That will all help us to go longer distances and spend longer time in space. Second, we need to get out of low Earth orbit. I believe the constellation architecture is one of the possibilities to do this and making progress every day. You're going to see that later. But however you frame it, we need a heavy lift capability. And no matter what options, I had recommendations there, but I was reminded you were making options, not recommendations. But whatever options you provide, I certainly hope that you will set an expectation that there are going to be bumps along the road, and there's going to be surprises. That's the nature of this business. I think third, as you think about, as you read through all the way back to your 1990 commission, all the way up through the one that just came out from General Lyles, there's a common theme in there that no matter what policy comes out of the options you guys present, I certainly hope that we will be reminded that or that you will remind them that the policy has to come with the resources to get the job done. Fourth, I think there's I kind of categorize this one as collaboration. I think there's huge opportunity for collaboration. We have fallen, in my opinion, into the trap of the tyranny of the or versus the power of the and. We have made it commercial or NASA instead of commercial and NASA. We have made it, that's something we got to fix. Because when you look at the capabilities I presented, and you look at the Space Act agreements, and you look at the things that we can do sharing the capabilities, to me that's an important thing to do. And that's not just commercial. That's us working with the international partners. I sat in the HTV review last week for the Japanese transfer vehicle, and it was one of the neatest reviews I've ever been in, because you had the Canadian Space Agency, you had JAXA, and you had the U.S. side talking about how we're going to actually capture this free flyer called HTV, and we're going to use the Canadian Army and go grab it. We wouldn't be doing this, right? We wouldn't be doing this if it wasn't for that opportunity. And that international collaboration is really important, and they do bring things to the table that we can use, no doubt. And then the final piece of the collaboration that I'll talk about is between, and I think General Lyles has this as his sub-team, so I'll just pile on, that the collaboration between us and other government agencies is something that I think we can take advantage of. Today we do it in little bitty pieces. We're helping the Air Force with the RS-68. They're using our propulsion engineers in some of our facilities to do some improvements on the main injector that they're looking at for RS-68. Okay, that's the one way. We use the Army here locally, not as much as we should, but we use the Army locally to help us with some of our solid motors that they pour for us, some of the smaller solids that we use, and then we test them over on the Marshall side. So I think there's room there to go do that, and frankly, it is the power of and, not the tyranny of or. And when you're in a resource-driven world like we are, I think that's what you got to look for as ways to get there. Finally, I guess I would hope that each of you kind of step back and think what got you interested in human spaceflight. Just for a minute. I know you can't do this very long. Step away from the architectures, the scenarios, the resources, and ask yourself why human spaceflight. I believe a section in your report dedicated to why human spaceflight, not assuming that people believe in it, but a section in your report dedicated to human spaceflight and why, presented to the President from this board, his chosen board and a very respected group in our industry, highly respected group in our industry, would be a powerful message indeed. A lot of us grounded explorers live our experiences of human spaceflight through folks like Dr. Wright and Dr. Chow. And while we can't share their same feelings, I think we can share the sense of accomplishment, of turning that impossible into the possible. It will inspire the next generation. I think you've heard what our folks said, and I didn't even bring 10% of what I got. It provides a place of leadership for this country. And you know, we've given that away in a lot of areas. It does provide us that leadership. And it also provides technical and economic benefits that I can't even begin to predict. Everybody always asks me, all I know is that if we don't do it, we won't get those benefits. We won't learn. So I believe we do stand at a crossroads for human spaceflight, and I think you have direction from the most powerful man in the world, President of the United States, to provide guidance for the future, for our endeavor. You've asked for input from a lot of folks, including me, a small-town kid who didn't know what an engineer was when he went off to school, and certainly never thought I'd be standing here talking to a presidential commission on human spaceflight. But my input's pretty simple for you guys. And I'll tell you what I told my folks when the commission was first formed. Recognizing that I'm from the University of Alabama and it's almost football season, so football kind of comes into play here. I told everybody the Augustine team's going to throw a pass. They're going to throw it to this new administrator, or the new administration and our new administrator. And our new administrator's ready to catch it. you hadn't noticed, he's pretty passionate about this stuff. He's ready to catch it. And all I ask is that you throw a pass that they can run with. When you do, this team at Marshall Space Flight Center and this community is ready to support any way that we can to continue this endeavor of human spaceflight. Thank you. Take questions if you got any.
Well, thank you very much. Your comments are not only very informative, but also very, very inspiring. And in the perspective of time, I'd like to ask two things that I'm going to ask my colleagues if they'll bear with me, and we'll just ask those two things of you. We'll have chances to visit with you at other times. The first is that you thank the people on your staff who arranged all the logistics for us. They've done a terrific job. More to the point, you've made some comments that a number of us probably are sympathetic to, one of which is that if we're to have a human spaceflight program, it ought to have goals that are exciting and that motivate people. Secondly, you made the point that we certainly agree with, is let's match the goals to the budget. Let's don't tell people to go do things and then not give them the budget to do them. We feel strongly about that. But when you put those two things together and look at you can see where I'm headed at the national budget challenges, there's a danger that the decision maker, whoever that might be, may just say, okay, we take you at your word, we're going to have to shut down. We can't do this. And are you prepared to take that kind of a risk?
I think that personally, I worry about a program that isn't, if we have a program that is not fully funded, it's kind of a dream, right? And we'll just get in a mode where we're not making the progress we need, and we can get into a mode where we do things unsafe. Personal opinion, okay? I think Mike Coates said it yesterday. He said there are no shortcuts. And I recognize the challenge. Don't get me wrong. I certainly recognize it. I heard it loud and clear yesterday, and I kind of knew it beforehand, but you guys presented some data that actually I had not seen yet. But I believe that if the country's going to do it, we need to do it. And I told some of my staff the other day, I said, this is kind of one of those big toe or all in. So I don't think we can get by with just putting our big toe in the water. I think we got to go all in.
Well, thank you very, very much. Unless any of my colleagues have something that's urgent to ask now, I think we'll march on. Again, we appreciate your comments, your leadership, and all that you and your team do.
Thank you for your time, and again, thanks for what you guys are doing. You've got a good challenge.
You bet.